Hello everyone. The title of this video is Finding a Linear Equation. And every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 2.2, Linear Equations in 1 and 2 variables. We'll see linear equations in 2 variables in this video here. And I'm working under the objective heading Finding a Linear Equation. Alright, so each example I'm doing is going to be either an example from this reading in the text or from one of the try it problems in the text or from one of the exercises at the end of the text, at the end of this section. I will also have timestamps in the description of the video below for when each example begins in this video. And I also request that whenever I start a new question, pause the video and try to work it out yourself first before watching me doing it and then comparing. Because if you're just watching me do these things and not practicing yourself, well, chances are you're not going to learn all that much. Alright, so I have all the examples written out on paper. Here we go. And like I said, the title is Finding a Linear Equation. Right? Given information about a line, we're going to be asked to write an equation describing all the points on that line in the coordinate plane, the xy coordinate plane. Right. So the instructions are: find an equation for the line with the given information, and then we'll be asked to write the equation for that line in 3 different forms. Alright, so all 3 forms will represent the same line, but just, look different. So there's point slope form, slope intercept form, and standard form. Okay, so before I even get into example 1 here, where we're given the slope of a line, and we're also told, it contains the point 2, 5. Let me go to a separate page here and talk about these different forms of a linear equation. Right. So the first of these is called point slope form. Right, and I personally like this one the best because I feel like it's the easiest one to write, in my opinion. But this is, you are given the slope m. Right, remember the slope of the line, the rise over run, the vertical change divided by the horizontal change, change in y divided by change in x. However you want to think about that. You're given the slope m, right, usually represented by lowercase m, and you also know a point, 1 point on the line. You are given a point on the line thus the name point slope form. And suppose this point has coordinates x1, y1, right? Or in some books I've seen x0, y0, whatever. Alright, so off in the coordinate plane, I'm going to make a little drawing of a quick xy coordinate plane. Right here's the x-axis and the y-axis. And we know a point on the line. Alright, So I'm just going to put that anywhere. So say here's x1 on the x-axis, and let's say here is y1 on the y-axis. So the point on the line is this point here. So there's the ordered pair x1, y1. Alright. Then we're told the slope as well, right? Or we can find the slope. We know the slope. Remember how slope can be used to go from one point on the line to other points on the line. Right? And here's how. Remember, slope is m, or m over 1. Right? You can think of this as m over 1 if you wish. Nothing wrong with that. So remember, this is rise over run, vertical change over horizontal change. So if I go, up or down m, I'm just going to go down here because of the way my picture is set up, but it could be up. Just understand that it could be in any direction. So I go down, m units, and if I go down m, then I go right or left, 1 unit. As long as the vertical change divided by the horizontal change is m to 1, right, is equal to m. And then here's another point on the line, right, up or down m, and then right 1. And, here's the line itself. Right, the line going through the point x1, y1 that has a slope of m. Right, so something like this. Now this one would have a negative slope, right, because it's going down to the right. If it has a positive slope, it's going up to the right. If it has 0 slope, it's horizontal. And if it has an undefined slope, it's vertical. And we'll talk more specifically about horizontal and vertical lines later. Alright, now, suppose I'm asked to, knowing this point, knowing this slope, I'm asked to write an equation that describes every single point on the line. Well, if you were to take any point, right, this point here, this point here, this point here, it doesn't matter. So if I were to take any point with an x-coordinate of x and a y-coordinate of y, right, so x comma y, these are variables, x comma y, and I'm making them variables because they can change. I can move this around to any point on the line, right? So this xy that I have here, this represents any point on the line, that isn't the point that I gave you, right? That isn't the point that we're given, right? Well, if you remember that the slope, the vertical change divided by horizontal change between any 2 points should always be the same, right? It's always this m. So recall the slope formula. Right? How do you calculate slope? Right, this lowercase m. Well, if I go between x1, y1, right, the point that I know, and any other point with an x-coordinate x and a y-coordinate y, the slope is, the change in the y-coordinates, y minus y1, right, y minus y1, divided by the change in the x-coordinates. And again, you got the order that you take the change in the y-coordinates needs to be the same as the order you take the change in the x-coordinates. So the unknown x minus the known x. Right. So we have m equals y minus y1 divided by x minus x1. Alright, and then we're almost there. To have an equation in what's called point slope form, you just take the slope formula here, the slope between a point that you know and any other unknown point on the line, and just multiply both sides by the denominator here. Multiply both sides by the quantity x minus x1. So we'd have y minus y1 on one side equals the slope times the quantity x minus x1. Right. So yeah, it just took the slope formula, slope equals change in y over change in x, and then just multiplied both sides by the change in x. So you have the change in y equals the slope times the change in x. Right? Again, between a point that you know and any other unknown point on the line. And this is called the point slope form of a line. Right here. And again, the reason it's called point slope form is hopefully obvious, because this x1, y1, those are the coordinates of a point that you know on the line, and m is the slope of that line, right? A point on the line and the slope of the line are revealed in this equation. And then x and y, these variables, represent x and y coordinates of any point on the line. Right. Wonderful. All right, so an example of this, let's go back to example 1. Let's go back to example 1 here, where we're given the slope of this line is 4, and we know it contains the point 2, 5. So m is 4. We have the m, the slope, and 2 and 5 are this given point on the line, right? The x1, y1. So x1 I'm calling 2, and y1 I'm calling 5, right? And then for any point on the line, right, for any point xy, right, again, I'm calling these variables because they can change, right? They're any point on the rest of the line, so they're not specific coordinates at the moment. But for any point xy, and the point 2, 5 here, right, the change in the y coordinates, y minus 5, should be equal to the slope 4 times, and then the change in x, taken in the same order that you took the change in y in. So the change in y, right, y minus 5, y minus y1, equals the slope of the line, right, 4m, right, times the quantity, the change in x, taken in the same order as the change in y, so x minus 2, right, x minus x1. And there you go. Right? Here is what they ask us for, right? An equation. Right? There's an equation of the line being described. Now what I'm going to do off to the side here is draw a little picture of that line, and then we'll go to a nice, better looking graphing calculator. See a better picture, but here's, the XY plane. Just making a rough hand drawing here. X-axis, Y-axis, right? And we know a point, right? Plot the point first, right? And then once you know a point on the line, you can then use the slope to get to other points on the line if you wish. So, x is 2, y is 5, and there's 1 point on this line. There's the ordered pair 2, 5. All right, and then we're told, right, that the slope is 4. So that means, between any 2 points, the vertical change divided by the horizontal change should be positive 4. So if I go from this point, if I go up 4 units, 6, 7, 8, 9, if I go up 4 units, I'd have to go to the right 1 to do 4 divided by 1, right? Remember, going up is a positive change, right? Anytime there's an increase in a coordinate, going up increases the y coordinate, that's a positive change. Going to the right increases the x coordinate, so that's a positive change. And anytime you decrease a coordinate, that's a negative change, right? So going down decreases the y coordinate, going left decreases the x coordinate. But if I go up 4, right 1, we're at this point here, 3, 9, right? 3, 9. This should also be on the line, right? And let's test that. All right, let me draw the rest of this in. I got 2 points now. I should be able to draw the rest of the line in. It should all fall on this line here. Something like that. I'm probably that we'll see what the x-intercept is in a second, but let's test it. Is the ordered pair 3, 9 on the line? Plug in 3 for x, 9 for y in the equation I just drew. So you have, on the left side, you have 9 minus 5 equals, 4 times the quantity, 3 minus 2. Left side is 4. The right side's 4 times 1, which is also 4. The answer is yes. All right. And so, I could use this equation now. And we can make a table, plug in values of x, get values of y. We can find all sorts of ordered pairs on this line. Okay. And so some other points would be if I went down 4, that'd be a negative 4 change, so I'd have to go left 1. So yeah, so I go down 4, left 1. The point 1, 1 should be on this. So this isn't the greatest drawing. Alright, this is not the greatest drawing. So let me actually take it to a website with a better drawing, right? Or if you have graph paper, be a little better, more ideal. But yeah, so here's a free online graphing calculator that I like using. It's at a website called desmos.com, DESMOS. And what I'm going to do is put in the equation for this line in point slope form that we found. Y minus 5 equals 4 times the quantity x minus 2. Alright, and then you can make a little table to go along with this. Well, actually, you can't because it's not y equals. Right, yeah, you got to solve for one variable, solve for y to be able to make a table. But let's just plot some points, right? We said 3, 9 should be on this, right? And let's zoom out so we can see it. There it is, right? 3, 9 is on this. 2, 5. Sorry, there's 2, 5, right? Okay, label, right? Which we already knew. And again, if I go down 4, left 1, that's the same as having a rise over run of positive 4. The point 1, 1 should be on this, right? There it is, and we can have it be labeled. Okay. But not only that, right? I can find all sorts of other points if I wished, right? Just find the x-intercept by replacing y with 0 and solving for x. Find the y-intercept by replacing x with 0 and solving for y. Right? You can do all sorts of stuff with the equation. Alright, so now I'm going to keep these up here and show you something else involving point slope form. So again, here's an equation in point slope form. But now, now I know some other points. We know some other points on the line. We know that 3, 9 is on this line. We know that 1, 1 would be on this line, etc. So some other equations, I could use these points instead of the 0.25, I could use the 0.39. And so we get other equations, another equation for this line. Instead of using 2,5, I use 3,9 instead. Do y minus 9, right, the change in y, equals the slope, right, 4, times the quantity, and then the change in x minus 3. And this is an equally valid equation for this line. And let me show you. I'm going to go back to that Desmos site. And let's just get rid of these points here. And I'll show you, right? There was the first equation, y minus 5 equals 4 times x minus 2. That was the point slope form of the equation I got when I used the 0.25. Well, here's y minus 9 equals 4 times the quantity x minus 3. And let me actually change the color of it. They're both red right now. Let's change it to blue. And look at that. It's exactly the same line. Alright, watch. So I'll turn the blue off. Red, blue, red. Again, if you're colorblind, I apologize, but you see that this second line, when I activate it, is lying right on top of the first line. They are the same line, just different looking equations because I used a different point. All right, so I'm going to do one more of these. Or, instead of using 3, 9 or 2, 5, I use another point on the line, 1, 1. Just do, change in y minus 1 equals the slope 4, right? That's never changing. The slope is always 4 times the quantity and then the change in x minus 1. And this should also be the same equation. It's an equation for the same line, as we'll see. And back on the website, let me put in that third equation. Y minus 1 equals 4 times the quantity x minus 1. And do you see there's no new line up there? Again, let me change the color. Make it like green, or I'll do green, yeah. Done. And then you see when I unactivate it, all these lines are the same picture. They're all the same graph, all the same line. I just used a different point. Same slope, right? They all have a slope of 4. That's never changing. It's the point that I use that changes. So the lesson here is that there are infinitely many versions of point slope form that you can write, because there are infinitely many points that you can choose from on a line. So there are infinitely many versions of point slope form for a given line. Alright, so that can be a bit tricky, right? Because which one do they want? Well, they didn't say anything about a specific one, right? I would assume, based on the fact that they gave us the 0.25, that they'd want us to use the 0.25, like in my first equation here. But again, you can use the 0.25 and then the slope, find other points like 3, 9, and 1, 1, and so on, and write, any other version of the point slope form for that same equation, for that same line. Right, great. So I hope that all made sense. That's a lot, right? But it's the change in y equals the slope times the change in x. Right? Just like it's just the slope formula manipulated a bit, right? Now, the next form, right? Slope-intercept form. Now this is probably the one most people are familiar with. All right, so same line here. So next form is slope-intercept form. All right, and this is in this form here. It's y equals m times x plus b, where m is of course representing the slope as usual, and b is the y coordinate of the y-intercept. Sometimes they just say it's the y-intercept. Right, the y-intercept, remember y-intercept is when you have an x coordinate of 0, and you can clearly see if x were 0, that term would disappear. You'd have y equals b. Right, so 0 comma b, whatever that point is, would be the point where the line crosses the y-axis. Right, so there's slope-intercept form. And very simply, just solve equation, whatever equation you're looking at for y, and simplify. Really, that's all you have here. See, y is alone on the left side here, and this side has no parentheses or anything, so distributive properties used, like terms are combined. So this is what you're doing to put an equation in slope-intercept form. Solve for y and simplify. So for our example 1 here, again, we have equations, right? We have equations, let me just take this first one. Right? The equation for this line with a slope of 4 and containing the point 0.25. Y minus 5 equals 4 times the quantity x minus 2. We solve for y and simplify. So first I'll distribute this 4. So now we have y minus 5 equals 4x minus 8, and then I would add 5 to both sides. Right, add 5, and that gives me y alone on one side. Right, y is solved for, and then on the other side we have 4x, and then negative 8 plus 5 is negative 3. Alright, and there you go. There's the equation for this same line. When x is 2, y would be 5. 2, 5 is on it. When x is 3, y would be 9, right? 3, 9 is on it. When x is 1, y would be 1, right? 1, 1 is on it. It's the same line. But now we can also tell that, the slope is 4, right? The coefficient of x, right? The coefficient of x, when you solve for y, that's the slope. The slope is 4. And now we also have the y-intercept. Right, the point where the graph will cross the y-axis will be 0, negative 3, right? The constant term is just the y-coordinate. And again, I'll show you, right? This is exactly the same line as all the others, right? All these point slope forms I had. So back on the Desmos site, right? I'll put in a fourth equation. Y equals 4x minus 3. And I'll change the color on that to orange. And you see it pop. That orange line is right on top of all the other ones. Right? Every time I activate it, you see it's exactly the same line. So all four of these equations are for the same picture. They represent, they describe the same points. Now, here's why I think more people remember slope-intercept form than anything. How many y-intercepts will a graph of a line have? Only one, right? So, you saw earlier, there are infinitely many points on a line. So there are infinitely many different versions of point-slope form. But there's only one y-intercept. So there's only one version of slope-intercept form for any given line. And I'll show you, right? Let's take this second equation, that we got here for the same line in point-slope form. All right, take y minus 9 equals 4 times the quantity x minus 3, and do the same thing. Let's put it in this slope-intercept form where I solve for y and simplify. Right? So first I'll do the distributive property here. I distribute the 4. We have y minus 9 equals 4x minus 12. And then I would add 9 to both sides, getting y alone equals, and then 4x minus 3. Hey, look at that. It's exactly the same, right? These are the same equation. And I promise you, if you took this third version of point-slope form that we got, y minus 1 equals 4 times the quantity x minus 1, and solve for y and simplify it, put it in slope-intercept form, you'd get the same exact thing, y equals 4x minus 3. Right, so that's the lesson from this, is that there is only one slope-intercept form for a given line, right? Which is nice. Right? There were infinitely many, point-slope forms that you could choose from, just depending on the point you chose on the line. But there's only one slope-intercept form. Right? I hope that's clear. Again, because there can be only one y-intercept. All right, and then finally, for this first example, and again, this should be pretty simple. They talk about standard form. Right? There's point-slope form, slope-intercept form, standard form. Right? So the standard form for a linear equation in two variables is, basically take all the variable terms to one side and all the constant terms to the other. It's, a times x plus b times y equals c, where a, b, and c are, now I've seen books where they just say it's any real number or real numbers. Okay, they can be any number you want. In this book, they're asking you, to make these into integers. So usually integers. Right? Usually they want again, in this particular text from OpenStax, they would like a, b, and c to be integers. But understand that in most books I've seen a, b, and c are any real number at all. Right? So, in our first example here, very easy. Right? Like I said, just just get all the x and y terms to one side, get your variable terms to one side, and then your constant terms on the other. So for example, the equation of the line we've been getting from example 1 here, we have y equals 4x minus 3. All I need to do to put this equation in standard form is subtract 4x. Get all the, get the x and y terms to the same side. So we have negative 4x plus y on the left equals negative 3. And there you go. This is in standard form, where a is negative 4, b is 1, right, that's 1y, and c is negative 3. Now if you want to multiply both sides by something, be my guest. You can multiply by both sides by negative 1 and make it 4x minus 1 equals 3. That's still in standard form. If you multiply everything by 2 and make it negative 8x plus 2y equals negative 6, that's also in standard form. Alright, so technically there are infinitely many versions of the standard form, right? You just take what you got, ax plus by equals c, and just multiply both sides by some number, and you'll get another equation in standard form as well. But I'm not going to write that out. But yeah, I'd say once you have the equation in slope-intercept form, it's easy to put it in standard form, right? Again, just take, or even in point-slope form, right? You're just trying to get it so that your x and y term are on one side, constant on the other, and in this particular text, if there are any fractions, just multiply both sides by the LCD, the least common denominator, and get your coefficients to be integers. Great, and once again, let me show you that this is the same equation. So we have a negative 4x plus y equals negative 3, and now it's in purple, and you see it's right on top of all the other ones. It's exactly the same equation, has the exact same points on it. Alright, so that was a lot, right? 30-some minutes there on one problem, but I wanted to introduce to you all these different forms. Point-slope form, slope-intercept form, standard form. Alright, and you'll see equations of lines in all these forms throughout the reading from this text. Alright, so let's get back into it. Alright, so that was all example 1. Right, so second example. So again, very nice of them. Right, they give us the slope of the line, negative 1/3, and it contains the point 1 1/3. Alright, so I'm going to call the coordinates of this point x1, y1. And then we'll go to point slope form first, right? We know a point, we know the slope, and that's all you need to write an equation for a line. Right, we can go to point slope form right away, right? For any point on the line, right, for any point xy, this will happen. The change in y, right, between this point and the any point on the line and this point I know. So the change in y, right, y minus y1, y minus 1/3, will be equal to the slope of this line, right, m, which is negative 1/3, times the quantity and then the change in x, x minus x1, x minus 1. And there you go. There's the an equation of this line in point slope form. And again, I'll make a rough hand sketch off to the side here. X-axis, y-axis. Hopefully this one's a little better. We'll see. Might not be though, because we got fractions here and whatnot. But when x is 1, and then here's negative 1 on the y, so and then positive 1 on the y, and then positive 1/3. Say I'm just eyeballing this here is about here, 1/3 on the y-axis. So here's 1/3. And then the slope, right, is negative 1/3. So that means if I go to the right 1 unit, if you increase x by 1 unit, you'd have to decrease y by 1/3, right? It's a negative 1/3. So that actually gives me a nice point here. 2, 0 is on this, right? 2, 0, that's the x-intercept. And if I were to go left 1, I'd have to go up 1/3, right? So 2/3, right? Again, as long as the rise divided by the run, and that's why I like running 1 unit, makes it easy. But here's the y-intercept, 0, 0, 2/3, right? And the rest of the line, should fall on this line here with these points, and I'll just draw again a rough sketch of there. There's the rest of the line, right, with arrows on the ends. All right, let's take a look at a better picture. Right? If you have graph paper or access to this graphing calculator here, or some other graphing calculator, go ahead and use that. What we got, y minus 1/3 equals negative 1/3, right? The slope times the quantity x minus 1. And here we go. And look at this. See, x-intercept 2, 0, as I had on my drawing. The y-intercept 0, 2/3, 0.666. They rounded it to 0.667, but that is 0, 2/3, right? And the 1/3 is on this as well, right? That's the point they gave us, right? 1, 1/3 is clearly on the line, right? You see it show up right there on the black line. Right? 0.333, 1/3 rounded to 3 decimal places. Okay. All right, so I'll keep this up, and we'll just keep finding different equations for it, and we'll see that it's all giving us the same line. And again, you can find, now that you have an equation, right? Now that you have an equation, you can find all sorts of other points by making a table, plugging in different values of x and get different values of y. So if I were to do that, I'm just going to do it for this one. You can do it for future ones, but x, y. A nice one here would be if x were 4. 4 you'd have y minus 1/3 equals, and then negative 1/3 times 4 minus 1, right, replacing x with 4. So this would just be negative 1, because 3 goes into 3 evenly, right? 3 cancels the 3. And then I would add 1/3 to both sides to get y equals negative 1/3 plus 1. Negative 1 plus 1/3 is negative 2/3. Right, so let's say that's about here. And then, here's a 3, 4, negative 2/3 should also be on this line, right? There's 4, negative 2/3. And that does fall on the same line. Again, my hand drawing is not bad, but if I go input 4, output should be negative 2/3. And plug in, whatever you want. And, plug in something for x, get something for y, plug in something for y, get something for x, and you can find other ordered pairs on the graph. All right, and then now let's take this equation in point-slope form, the easy one to write, and put it in slope-intercept form. So I'm going to distribute the negative 1/3. So we got y minus 1/3 equals negative 1/3 times x, and then negative 1/3 times negative 1 is positive 1/3. Right, and then I would add 1/3 to both sides to get y alone. Get y equals, negative 1/3 times x, and then 1/3 plus 1/3 is positive 2/3. And here we go. All right, this is, solved for y and simplified. This is in slope-intercept form. right? And you see the slope is the coefficient of x, right? Y equals mx plus b. M is negative 1/3, you know, as we were told, the slope is the coefficient of x here. And then 2/3 is the y-coordinate of the y-intercept, as we already saw in my drawing here. The y-intercept is 0 2/3, which we're seeing, you know, positive 2/3 here, plus b. Excellent. And again, I'll pop that into the Desmos site, and we'll see that, you know, it's exactly the same equation. Gives us the same points, the same line. Y equals negative 1/3 times x plus 2/3. And see, it's the exact same line, right? Shows up right on top of the other one. Great. All right, and then finally the standard form. Again, very simple, very simple. Now, especially if you have it in slope-intercept form already. You know, here I have negative 1/3 x. You know, get the x and y term to the same side. I would just add 1/3 x. So you have 1/3 x, right, positive 1/3 x plus y equals 2/3, right? Positive 2/3 would still be on the right side. And this is in standard form, normally, right? But like I said, in this particular text, the authors want the coefficients to be integers if possible. So right now I got some fractions here. The least common denominator, right, the LCD for this particular equation is 3, clearly. So then I multiply both sides by 3. Right, multiply both these terms by 3, right, which I'll have to distribute because there's multiple terms over there. Multiply this side by 3. And then, you know, the coefficients will all be integers. You'll have cleared those denominators away. So the first you got x plus, and then 3 times y is 3y equals, and then 2/3 times 3. The 3's cancel, you're left with 2. All right, and then there you go. This is what they want. They want the coefficients of, you know, all these coefficients, all these numbers a, b, and c. Ax plus by equals c. They want a, b, and c to be integers if possible. And here's standard form, right, for that same equation. Right. Again, I'll pop that in, and we'll see that it is indeed, you know, just to check my result, see that it's indeed the same equation. X plus 3y equals 2. And look at that, it's right on top of the other two, right? It is the same equation, the same points. Wonderful. Okay, so I'll clear these out, and we're done with that. We're done with that question now. All right, so now we're going to move on to a new kind of line. All right, we've seen a line with a positive slope. We've seen a line with a negative slope. All right, so look at this point here. Now this example 3. I see in example 3, they don't give us a slope. All right, they don't give us a slope, but they do give us 2 points. So we know a point, you know, say negative 5, 2 or 2, 2, it doesn't matter, just pick one. We need to find the slope if we're to write the equation of this line. So remember the slope, m, remember that was the change in y coordinates, so 2 minus 2. I'll do second minus first. 2 minus 2 divided by, and then the change in the x coordinates, you know, taken in the same order, 2 minus negative 5. Well, numerator is 0, denominator would be 7, and 0 divided by some non-zero number is a 0. Slope is 0. Now, that's not the answer. But hopefully you recall from the previous video on slope of a line, when the slope is 0, that means we have a horizontal line. A horizontal line. Right, watch this. Right, I'll plot these points. Right, again, a very quick XY plane, and you know, every single point on this line is going to have the same y coordinate, right? You see both of these have the y coordinate of 2. You got 2, 2, and negative 5, 2, negative 5, 2. And you know what else would be on the line, right? 0, 2, and negative 1, 2, and negative 2, 2. All these points here, it's a horizontal line. But every single point has the same y coordinate. So the equation of a horizontal line is y equals some number, y equals c, right, where c is constant. And you really don't have to put this in any other form, right? I know there's point slope form and slope intercept form and standard form, but for a horizontal line, you only need to put the equation in this simple form here, just y equals c. And c is the number, that is always the y coordinate. So the equation for this line is y equals 2. Right? Y equals, the y coordinate is always 2. Now if you want to put it in slope intercept form, that'd be y equals 0x plus 2, right? The slope is 0. If you want to put it in slope intercept form. If you wanted point slope form, right? Let's say I just pick this point here, 2, 2. Go y minus 2 equals 0 times x minus 2. Right? But you see how the right side is just 0. And then I would add 2, get y equals 2. And then if you want standard form, you'd have 0x plus y equals 2. So there's slope intercept form, here's point slope form, here's standard form, but again, all of these are boiling down to just y equals 2. Alright, so for a horizontal line, slope of 0, it's just y equals the same number every time. Y is always equal to 2 here, and that's all you need to write. That's all you need to write. Alright, and you'll see later, it's very similar for vertical lines. When a line is going straight up and down, the x coordinate is always the same. So it's just x equals some number. But let's continue. Let me actually again show you on a better grid here. Just y equals 2, right? And again, if you don't like, if you want y equals 0x plus 2, same thing. Y minus 2 equals 0 times x minus 2, same thing, right? 0x plus y equals 2, same thing, right? It's kind of ridiculous though when coefficients are 0, right? I'd rather not write things with a coefficient of 0. Alright, so just keep y equals 2, and you see every single one of these points has a y coordinate of 2, no matter where you slide it around. Y coordinate's always 2. Okay? Great. Alright, now the next one actually has, a slope that's not 0 anymore, but, this one's nice because look at the point we're given, right? So once again, we're given a slope, we're given a point, right? So, and that's what you need, right? You need a point, at least one point on the line, and the slope of that line to be able to write an equation. I'm given a slope, m is 2/3. Also given a point, 0, 3. But the nice thing about this point too is that this is the y-intercept as well. Right? See, the x-coordinate is 0, so this point is on the y-axis. This is the y-intercept. Alright, so first I'll do point slope form. So remember, for any point xy, you take the change in y, which will be y minus 3, equals the slope, right, m, 2/3, times the change in x, which is x minus 0. But nobody writes x minus 0. All right, x minus 0 is just x. So we have y minus 3 equals 2/3 times x. Right, and this is what I'd consider point slope form. Now again, either one of these is fine. They're both the same. It's just subtracting 0, doesn't do anything. That's silly. Silly to write that. And then since you see the y-intercept is 0, 3, they already gave it to us. So I have the slope. I have the y-intercept. I can write this in slope-intercept form immediately. It's just y equals, mx, right? 2/3 times x, the slope times x, plus the y-coordinate of the y-intercept, which would be 3. Now again, I know it's obvious, see my point slope form here. If I just solve for y, all I would have to do is add 3, and there you go. There it is. Y equals 2/3 x plus 3. And then, to get it in standard form, remember I take everything with the variable to one side. So here I would subtract 2/3, so we have negative 2/3 times x plus y, equals, you'd still have the 3 on the other side. And then, just to be consistent and stick to what this particular text I'm in wants. The LCD here is again 3, so I'm going to multiply everything by 3. That'd be negative 2x plus 3y equals 9. And there's the standard form, that they're asking you for. Again, I would still consider this first equation in standard form as well. But they want you, if it's possible to make all these numbers integers, please do it. All right, again, let me write these out. Let's take a look, make sure that they're actually the same equation. So my point slope form, we're at y minus 3 equals 2/3 times x. Cool. Positive slope there, rising to the right. And you can find all sorts of all the ordered pairs you wish now that you have an equation. Make a table. Slope-intercept, y equals 2/3 times x plus 3. Look at that, right on top of it, same line. Standard form I ended up with, negative 2x plus 3y equals 9. And look at that, same line. Shows up right on top of the others. All right. Wonderful. Fantastic. Okay. So next example. All right, so this one's a little different as well. See, we're not given the slope. We're not given the slope, but we are given the x-intercept. Right there. Now, sometimes if they give you just a number, you can still tell me what point that is. Right? If I say the x-intercept is 1, that means that the point 1, 0 is on the line. Right? The x-coordinate of the x-intercept is 1, and if you're on the x-axis, then the y-coordinate is 0. Alright, so now I have 2 points, and you just need a point and a slope to write an equation for a line. Well, I have 2 points, so I have a point at least. Great. I just need the slope now. Right, and again, the slope you should know how to calculate when you have 2 points. I'll do this point minus that point, right? So remember, this is a change in y in the numerator, 6 minus 0, divided by the change in x in the same order. So I did 6 minus 0. For the change in x, I have to do negative 2 minus 1. That's 6 in the numerator, negative 3 in the denominator. So this is negative 2. This line has a slope of negative 2 and passes through these points. Alright, so first I'll write the equation in point slope form. Using this point here. It doesn't matter. Pick negative 2, 6 if you want. Pick 1, 0 if you want. It doesn't matter. So remember the change in y, y minus 6 equals, or y minus 0, right, which is just y, equals the slope, right, the slope is negative 2 times the quantity x minus negative 2. Now x minus negative 2 is x plus 2, right, so that's x minus negative 2 in parentheses there. And there you go. There is, an equation for this line that, in point slope form. All right, and then I'm going to solve for y, right? So this is y minus 6 equals, negative 2x minus 4 after distributing the negative 2 and then adding 6 to both sides. All right, I get slope-intercept form. Be y equals, negative 2x, and then you have negative 4, and then be adding 6, it'd be plus 2. So the y-intercept is at 2, right, the point 0, 2. So we got 1, 0 for the x-intercept, the y-intercept would be 0, 2. And then look at that, all these numbers are already integers, so standard form is easy. Just add 2x. We have 2x plus y equals 2. And all the coefficients are integers already. So no need to multiply by anything. This is the standard form they're looking for. And there you go. All three of these equations describe the same line. And let's take a look at that, right, just to verify. So my point slope form, y minus 6 equals, the slope was negative 2 we found, times x minus negative 2, or x plus 2. Right, and you see a negative slope, it should be going down to the right like this is. The slope-intercept form, y equals negative 2x, right, the slope times x plus 2. And again, same line, right, you see 0, 2 for the y-intercept, 1, 0 for the x-intercept, as they already told us, right, that was given. And then 2x plus y equals 2, and exactly the same line, right, all three of these are right on top of each other. They represent the same points, the same line, but just in different forms. Wonderful. All right, and again, you can do these graphs by hand if you want. And you saw, I did a couple graphs by hand early on. They're not the greatest, right? If you have graph paper, that would be ideal. But I'm just going to keep verifying that these are all the same line with the Desmos website for now. Great. All right, so the next example is pretty similar, where again I'm not given the slope, just 2 points. But I need to find the slope, right? In order to, one more time, I'll say this almost every problem. In order to write the equation of a line, you need a point on the line, which we have 2 of them, and the slope. You need the slope as well. All right, so m, right, lowercase m. Now remember, 2 points are needed, to find the slope. And I'll do second minus first, right? So remember the change in y, negative 6 minus 10 in the numerator, divided by the change in x in the same order, 5 minus negative 3, which will be 5 plus 3, right? So we have negative 16 in the numerator, and then 5 plus 3 is 8, and then this is again negative 2, right? Lucky us. 2 problems in a row with a slope of negative 2. Alright, so now I have the slope, and I have a point, and I just pick one. I'll take this one here, negative 310. And we can write the equation very easily now in point slope form. Remember, it's change in y, so y minus 10, right? Y minus 10 equals the slope, negative 2, right, times the quantity of the change in x. So that'd be x minus negative 3 from this point that I picked. But that's x plus 3, right? X minus negative 3, and there you go. This equation is the equation of the line that they described, right? It would have this point in it and this point. And you can check, Replace x with 5 and y with negative 6, and you'll see that this is a true statement. Replace x with negative 3 and y with 10. You'll see this is a true statement. Right? And you can find other points by making a table and junk. Right? Alright, then I distribute the negative 2. We're going to solve for y here and simplify. Right? We have y minus 10 equals negative 2 times x minus 6, and then I would add 10. Get y equals negative 2 times x, right? The slope times x. And then negative 6 plus 10 is plus 4, right? So the y-intercept would be at 0, 4. There's slope-intercept form. Y equals mx plus b. Right? And again, it's very nice that all these coefficients are already integers. So all I need to do is just, for standard form, add the 2x. You have 2x plus y equals 4. And there you go. All the coefficients are integers like they want in this particular text. And there we go. And once again, you can draw by hand or whatever, but I'm going to just verify that all these are the same line by just plotting them in this graphing calculator here. Alright, so the point slope form, y minus 10 equals negative 2 times the quantity x minus negative 3, or x plus 3. Cool. Then we had y equals negative 2x plus 4. Same line, see that? Exactly the same, right on top of it. And then 2x plus y equals 4, exactly the same line, right? Fantastic, right? And the y-intercept, right, 0, 4, as I said when we had the slope-intercept form, right? X-intercept is at 2, 0, but again, you'd have to plug in 0 for y and solve for x in some of these to find the x-intercept. Right? But that's easy enough. Great. All right, next example. Now we have talked about horizontal lines, right? That was an example 3 or 4 earlier in the video, where the points had the same x, y coordinate all the time. Well, look at here. You have negative 2, 0 and negative 2, 5. You see how these have the same x coordinate. So watch what happens, right? If I try to find the slope, it's going to be the change in y in the numerator, 5 minus 0, divided by, and then the change in x, negative 2 minus negative 2. So the numerator is 5, but the denominator would be 0, and right? Can't divide by 0. Can't divide by 0. This is undefined. Alright, so the slope, m, is undefined. So here's another line that I can't really write the equation in slope-intercept form or any of those other forms. And hopefully you recall, and from my previous video on the slope of a line, that when the slope of a line is undefined, you're going to have a vertical line. Let me draw this, right? Again, a very quick xy plane over here. And you notice again that these 2 points have the same x coordinate. I go to negative 2 on the x, and you got these 2 points, right? Negative 2, 0, right? That's the x-intercept, and then negative 2, 5, and these are directly above and below each other, right? This is a vertical line, straight up and down, parallel to the y-axis. Right. Now, if a line is vertical, the equation for that line is very simple, just like for a horizontal line. The x-coordinate is always the same number, right? So the equation of a vertical line is x equals c, where c is a constant. And there we go. Right, so for this particular one, notice the x-coordinate is always negative 2, and that's it. this is the equation for this vertical line, right? A line with an undefined slope. And that's all I need to write. Now you could write, x plus 0y equals -2 if you want it in standard form or whatever, but remember, having a coefficient of 0 is kind of silly, right? Why bother writing it if it's just going to be nothing, right? And then back here, just see what happens when I put in, x equals some number, right? X equals -2. See, it's a nice straight up and down vertical line. And every single point on this line has an x coordinate of -2. Okay? That's it. It's that simple when the lines are vertical, when the lines are horizontal. Very, very simple stuff, in my opinion. All right, so the next one is pretty much the same thing. See, we're told in example 8 that the slope is undefined, right? When the slope is undefined, means it's a vertical line, right? And when the slope was 0, that was a horizontal line. And it contains the point 2, 3, right? So I can draw a very, very, very quick sketch of this. Right, here's the point 2, 3. And I'm told the slope is undefined. So there's no change in x. That's what that means. So it's a vertical line. This is going to be going straight up and down. So not only is 2, 3 on this, but so is 2, 0, and 2, 1, and 2, 2, and 2, 5. And the x coordinate is always equal to 2. And there we go. That's the equation of our line, and that's all I'm going to write. There's no slope-intercept or anything like that for that. There's no y in it, right? It's just x equals 2. But undefined slope was the key there. And once again, very, very quickly, just verify x equals 2. See, vertical line, this green line that just popped up. And it's got the point, it's got the point 2, 1, 2, whatever, right? Every single point on the line, no matter where I move this to, has an x coordinate of 2. And it definitely has the point, 2, 3. You saw it, it popped up there a second. I could plot it, but yeah, very, very simple stuff when the slope is undefined or when the slope is 0. Right, when it's a vertical line or horizontal line, very, very easy. Okay. Right. And then we're going back to the, like in example 1, right, just one last one here. Now we're back to where the slope, the slope isn't 0, the slope isn't undefined, it's, positive 3/4. And it contains the point, 1, 4. So easy enough. Y minus 4, remember, change in y equals the slope, right, 3/4, times the change in x, the quantity x minus 1, right, using this point I know and the slope. And there's the equation of the line in point slope form. Alright, then I would distribute the 3/4. We get y minus 4 equals 3/4 x minus 3/4. And then I would add 4 to both sides, which is 16/4. Remember, when you add numbers and subtract numbers, you need a common denominator. Right. So 16/4 is the same as 4. Right? And then now these have the same denominator. So we have y equals, 3/4 times x, the slope times x. And then negative 3/4 plus 16/4 is positive. Remember, when you add things with the same denominator, that denominator stays. You just combine the numerators. Negative 3 plus 16 is 13. And here's, slope-intercept form. All right, so the y-intercept is at 0, 13/4, right, which is like 3.25. Right, and I'll show you that on the graph. that it crosses the y-axis at 13/4 at 3.25. And then I take away 3/4 x, we get negative 3/4 x plus y equals 13/4. And the LCD here is 4. I multiply everything by 4. We get negative 3x plus 4y equals 13. And there's the standard form that they want, right, with integer coefficients for that same line. And again, let me just pop all these in. We'll see the 0.14 is on it. We'll see the 0.013, so 3.25 is on it, and all that jazz. Right. So y minus 4 equals 3/4 times the quantity x minus 1. All right, and you see, look at this. See, 0, 3.25. Right. The y-intercept was at 13/4. And let's see that the y equals 3/4 times x plus 13/4. Right, same exact line. I don't know why all these points showed up, but there they are. But it's the same exact line, right? Appeared right on top of it. And then negative 3x plus 4y equals 13. Same exact line. Fantastic. Right. Okay. So, I know this is a long one. All right, but I really just want to get those forms introduced to you, and also the equations for horizontal lines and vertical lines show up throughout this video as well. And just remember that to write an equation for a line, you need to know a point, at least one point on that line, and the slope of that line, right? And then you should be able to write an equation for a line, the rest of the line, describe all the points pretty quickly. Great. So I'm hoping that watching me go through these 9 examples here helps you in some way when you're asked to write the equation of a line, find a linear equation on your own. And thank you very much for watching.